In this video, we're going to take a look at optimizing Multicast VPN. We're going to leverage the MDT data tree in this particular video, and this is going to allow us to make our Multicast VPN a little bit more scalable. So a new tunnel is created between the ingress PE and the egress PE. Source-specific multicast is recommended for this configuration, and this enables you to specify the source and group info. Now, what we're going to do is we're going to enable SSM globally on all the routers. Now, what ends up happening when you do this is you configure this on all core routers. On iOS, you have to type in IP PIM SSM default, and you're good to go. And you might have noticed in the introduction, beginning of the this section, that XR runs this by default, and you can see that with the 232 range. So we're going to be migrating to the 232 range as we go forward here. And the configuration is going to look something like this. On iOS, underneath the VRF, we're going to change the MDT default range to 232.1, which is going to be the control plane multicast address we're going to join on all the PE routers. And then for the data tree, we're going to use the 232XX, where for router 3 it's going to be 232.3.3.0/24, which will give us up to 255 group addresses we can leverage per PE. And then the 232 range is for SSM configuration. On XR, we're going to do the exact same thing. We're just going to be tweaking the configuration. Now, one thing to keep in note is this does not require us on the customer side to configure IGMP version 3. What this does require us to do, though, is we need to make sure that when we're rolling this out, we're not going to be modifying the customer at all. This is all provider core optimization. Now, what this is going to do on the core is the SP core should now do the following. There should be an S(G) entry for each PE and the group address locally configured, and you'll see a lowercase s and a capital T flag indicating that SSM is being used. So we're going to go ahead and get this rolled out. So what we need to do here is on all of the provider edge routers, we need to modify the configuration so that everybody is going to have the same outputs. So on R3, we're going to start there because we want to start on iOS and then migrate and then do the XR configuration. So on here, we're going to go to global config and type in underneath VRF definition customer B, underneath address family IPv4, we're going to type in that the MDT default is going to be 232.0.0.1. Remember, this is for the control plane for source-specific multicast. We're going to type that in. It says 239 is already in use, so we're going to type in do show run VRF customer B, and we're going to go to here. We're going to type in no, and a new tunnel ID may be used to identify if the default MDT is reconfigured for this VRF. That's exactly what we're going to do. Notice how the tunnels go down. We're going to come up here and we're going to type in this. That's going to cause that. And then what we need to do now is we need to type in MDT data is going to be 232.3.3.0/24. Or is it? I think it's a 255. Nope, not a IP multicast group. There we go. So it's a reverse wildcard. So we're going to go ahead and do that on all the other routers. The one thing that we have to do as well is we have to type in IP PIM, and then under here default, or it's going to be SSM default. So we're going to use the 232/8 group for SSM, and that's going to be how we go about moving forward. So now what we have to do is go to XR1, get him situated, log in, and if we do a config T and then a multicast routing, I type in VRF customer B and type in address family IPv4. We're typing MDT default is going to be 232.0.0.1, and that the MDT data is going to be 232.111.111.0/24. We do a show config. We don't have to worry about anything else, and we're going to go ahead and commit that change. So that's going to bring that going to change that guy. We're going to go to XR2 and just repeat the process. Now the difference between the two is I'm going to tweak the configuration just slightly. So instead of this being, this is going to be a 2, this will be a 2, and we're going to go ahead to the end and get that guy situated. So we're going to go up, log in as myself, go to global config, and commit that change, and then do the same thing on XR3. And tweak the config there as well to make this a 3, make that a 3, and there we have it, folks. So what we've effectively done is we moved it away from the PIM dense mode style paradigm. So now if we go to R3 and come in here and do a show IPM route, you're going to see a couple different configurations here. So we're going to see the rollout here, and you'll see eventually that this will be phased over. We're going to go ahead and clear the IPM route star, and that should repopulate here momentarily. Give that some time to flip over. Show IP PIM neighbors. So we're good to go there. We should start to learn the stuff back in here momentarily. So what I'm going to do at the same point in time is I'm going to go ahead and on R10, I'm going to go to all the routers around the network. I'm going to go to router 8, and on this interface, show run interface gig 1.38. I'm going to take the join group off here. So I'm going to type in here, no join group this guy. I'm going to selectively change the group addresses. I'm going to have I'm going to join 8 and 9 to one group, and I'm going to join 6 and 12 to another one. And we're going to type in IP IGMP join group, join dash group. Oh, IGMP, sorry. IGMP join group of 224.89.89.89. And I'm going to do the same thing on R9. Show run interface gig 1.30 or 129. Interface gig 1.129, and I'm going to pop this one in here and pull this one out. So now I'm going to go over to router 10, or I'm sorry, 6. Go to router 6 and do this. Interface gig 1.613 and type in IP IGMP join group of 224.126.126.126 and do show run interface gig 1.613 and no to this group address right here. I'm going to grab this one right here, and away we go. Over to 12. We're going to go into interface gig 1.1211. Drop that in there. Do show run interface gig 1.1211. And no group join for this guy. So now we're going to go back to router 3. And that should be... This should start. Do show run section VRF. So I have the configuration in play there. Let's see. Interesting. Why is that not working? Let's see. XR1. Show MRib route. Okay, so I have XR1 has joined, and he sees that. Loopback 0 is my incoming interface list, which is good. I see the 232 in here, which is what we would need. Let's go to XR2 and see him. Show MRib route. We see XR2 here for 232. But we don't see XR1. We see our local configuration. So I've got to go show MRib route. We see that guy. So I'm going to go ahead and we should see more coming in as we go along. There is we should see for, if I was to do clear mrib, or is it mfib database for, and let's see if that, there we go. So that cleared it out. So I'm going to go to XR2 and do the same thing. So clear mfib database. That'll clear that one out, and this one will clear here. So clear mfib database, and then I should have the 232 range in here, which is what I would expect to see. So now I've got to make sure that all of these guys are joining that. So we should see S, G for every one of these connections here, and I have to see why I haven't joined that. Let me go to, I don't show run section IGMP. That's what I thought. I'm not running, I don't need to run IGMP here. Let me see why this is not working, and I'll bring you guys back in and show you the solution. So after a little bit of troubleshooting and just taking a look at the verification steps that we've been going through, one of the things that we did in the default MDT that we didn't do before was we were doing before that was affecting our progress here was the fact that we were using BGP route reflection, where R1 was a route reflector for the IPv4 default MDT. Well, that was causing us a problem where we weren't getting the information to propagate via BGP. And the problem that we were running into was because of the fact that the default MDT will join no problem because it's one common join for all of the PE routers to the network. Well, that worked out quite well. The problem with that being, though, is in the data MDT, that is a different paradigm. We need to, because what we're doing is we're moving away from the rendezvous point design in the core, and we're moving to a source-specific point-to-point connection, to where if I don't need to send data to a specific PE, I'm not going to. So we're going to go ahead and disable the debugs, and you all. So if I go in here and I do a show IP PIM neighbor, I'm joined to my neighbors, which is my PIM adjacency. But do a show IP PIM interface, I'm joined to those interfaces. Show IP mroute, before I wasn't seeing this. And what I need to see in here, but what I wasn't seeing earlier, and I'll scroll this up just a little bit, I was only seeing this. I was seeing a single entry in the mroute table, and I'm like, wait a minute, that's not right. That shouldn't be the case. But one thing that I was doing differently in this video than I did when I was testing prior to this was I wasn't using route reflection prior to the demonstration. I was using BGP route reflection for everything else. We've used route reflection this entire time. So what ends up happening here is we end up getting a issue where we have a break in the control plane where traffic won't be forwarded. Now, in the case that we're running into here, I have the connectivity where I need it, right? We have everything working the way we need it to. Now, here's the test. What I've done is on R8 and R9, I've joined them to 224, 89, 89, 89. And on R6 and R12, I've joined them to 224, 126, 126, 126. So I'm going to go back to R10, and I'm going to do a ping to 224.89.89.89 and a repeat of 5 times. So I should get a response now back in from 8 and 9. So it'll take just a couple of moments for that to happen, but what you'll notice, and when we go into do the configuration, routers, we won't be sending the data to R12, and we're not going to be sending the data to R6 because of the fact that we're looking at a data MDT. R12 and R6 are not joined to that group, right? So we're not going to be receiving responses from them. We will receive responses from 8 and 9, and that's the only place we're receiving that from there. So that's the case in point here. So the problem that I was running into was I was using BGP route reflection on R1 to propagate the routing information. By migrating away from that and using point-to-point or full mesh configuration, that resolved my issue. Now, do I know if it's that's if there's a workaround for route reflection? I honestly really have no idea. I haven't spent the time to dig into that aspect of it. What I wanted to make sure that we could get working was we would get responses from here. So I'm going to go ahead and Control-Shift-6 on that to break the ping. What I'm going to do now is I'm going to change it up to ping a different multicast address family, 126.126.126. So now I should be able to reach out to R6 and R12 and get responses from those two IP addresses. So 613.0.6 and 12.11.0.12. I should get responses from both of those IP addresses, which will indicate to me that I have two multicast address groups, and I am selectively pinging the ones that I want to talk to. And if I don't ping, if there's a router not associated to that group, it shouldn't receive a ping from it. So that is one of those situations. So just so everybody's clear, there's actually a misunderstanding that I've been reading online. I've actually been pinged by quite a few people recently that multicast is absolutely supported in the data plane. It is absolutely supported in XRV and iOS, as you can tell. And how you can verify that is I have to go from R10, I have to go through XR1 to get to R12. So it is absolutely supported. And these are data plane packets that I'm sending. So the only limitation I've seen on XRV thus far in my preparation, BFD is not supported, Layer 2 VPN is not supported. Beyond that, I have not seen very much, I've seen very little that is not supported. Now, I'm sure that there's going to be a few that I run into down the road that I haven't been able to test on. Your PBB EVPN is one of those things that is not supported as well in the data plane. Beyond that, all the control plane for almost everything works except for BFD. Even your layer 2 VPN, your pseudo wires, your VPLS, XRV supports that in the control plane, just not in the data plane forwarding. But beyond that, you're able to see all the data that's going across the network. So that is your data MDT.